Hello dear students, how are you all? I hope you are all good and studying very hard. Let's solve another problem from book Irodo, chapter Kinematics, and the problem number is 1.15. This problem is based on elevator and bolt. Like you must have done this kind of problem, and this is really interesting problem. This problem is the toughest that can be formed on lift and bulb problem. So let's read this question and solve this. An elevator car whose floor to ceiling distance is equal to 2.7 meter. Let me draw elevator, how this elevator is. So this is an elevator. Let me draw it for you. Okay, fine. This is an elevator and they are saying that the elevator to top to floor, ceiling to floor distance is 2.7 meter. Okay, just write it here, 2.7 meter. Now this lift is accelerating. Ascending means moving upwards, so ascending with constant acceleration of 1.2 meter per second square. Okay, fine. This lift is moving upward with acceleration of 1.2 meter per second square. Okay, fine. 2 seconds after the start. 2 seconds after the start. So okay, start, that means initial velocity of the lift was 0, and after 2 seconds, so let's say this is 2 seconds, this is 2 seconds, a bolt begins falling from the ceiling. Okay, fine. This is a bolt and it just detached from the ceiling. Now we have been asked find bolt's free fall time. Okay, this is really easy question and really interesting. If we solve this question from the ground frame, then you will see we have to do some equations, but you will see if we solve this problem from in the frame of lift, then you will see this problem will become one line question. But I will tell you both method. So let's solve this question from ground frame first, how it will be solved in ground frame, and then let's solve this problem in frame of lift also. Suppose there are two persons, one person is in lift which is at rest, just standing, and there is one more person on the ground. Let's name them A and B. This is on the ground, so this is at rest. At t is equal to 2 seconds, you can find what will be the acceleration, what will be the velocity of lift. So if this lift is accelerating with 1.2 meter per second square, I think v is equal to u plus at, u is 0. I can say that this lift and bolt just before t is equal to 2 seconds, because at t is equal to 2 seconds this bolt has detached, but just before t is equal to 2 seconds I can say that this bolt and lift both are moving with velocity v is equal to u plus at, and u is 0 for lift at t is equal to 0. At let me write it because this is important. At t is equal to 0, velocity of lift was 0, right? At t is equal to 2 seconds, v is equal to u plus at. So a is 1.2 into t to 2 seconds, that is 2.4 meter per second square. 2.4 meter per second. This is the velocity. Now from the ground frame, what this person is observing, that this bolt is having initially upward velocity, so obviously this ball will go some upward distance, and as soon as it detached from the lift, the only force that is acting on this bolt is mg, right? So this is just after the detach, or let me say after detaching, this bolt will be moving only under the effect of the gravity, or let's say it is falling freely. That's what we call free fall. If a particle is doing motion only under the effect of the gravity, we say that the particle or object is in free fall. So this block is having, this bolt is having now acceleration of for, let me write it here, for t greater than 2 seconds, because after 2 seconds only we have started observation. I will say after t is equal to 2 seconds, acceleration of a bolt will be equal to 9.8 meter per second square, and let me put minus because I am taking upward as positive. for this person ground, upward is positive. Now for t greater than 2 seconds, acceleration of bolt is 9.8. I must say g. So I must write only g only. So you will understand I took g as 9.8 meter per second square. So and its velocity is plus 2.4 meter per second, right? Now it will go up, and by the time it will come down, when it will strike the floor, you will see by the time it will come down, this floor also move some distance upward, right? This is the floor of the lift. So by the time this bolt will strike the floor again, this floor must also have moved some distance. Let me say this, let me write with black pen. The distance moved by the bolt must be by the lift must be SL, and by this time this must be whatever time it is. At this time, by this time the lift has also displaced in downward direction actually. So this is displacement of lift, and let's say magnitude of displacement of lift. We know that displacement is in a negative direction, and let's free fall time is tau. Free fall time is tau. So this is the time at t is equal to 2 seconds. This bolt was detached, and let's say at t is equal to 2 plus tau. Why I am writing 2 plus tau? Because tau is the time interval or free fall time, and we have started observing at t is equal to 2. So obviously the duration is tau only. Now for this tau duration, we can say from the ground frame, if you want to solve this question, we know that this displacement of lift plus displacement of magnitude of displacement of lift plus displacement of this is bolt, not lift, this is bolt. So magnitude of displacement of bolt plus magnitude of displacement of lift, sum of both this number must be equal to 2.7. So this is the equation which we will apply. Displacement of bolt plus displacement of lift is equal to 2.7, and this is how you will solve. Let me write equation also for you. As we know that displacement of bolt is going to be in downward direction. So for solving the displacement of, for finding the magnitude of displacement of bolt, I can assume different convention for bolt also. Like for bolt, let's say downward direction is positive, so I can use this also, but let's take this convention only, as we know that by this convention displacement is going to come negative. So we know how to open mod. If we know that displacement is negative, then we will put extra minus sign outside, because we are applying mod, we want magnitude, right? So as displacement is negative, I am going to apply put a minus sign in advance, and write displacement of this bolt. So I will write ut plus half it square. U is 2.4 into t minus half into g. G is 9.8. So let me put it 9.8 into t, not t, tau. This is because in this equation we always write the time interval, right? You remember time interval. So we must we must write tau here, tau, and half into a into tau square. This is now displacement of lift. We know that displacement of lift is in upward direction, so we don't need to put any minus sign outside because it is already positive. So u of lift, this initial velocity of lift is also 2.4 into tau, because we are talking about this interval only, plus half into acceleration of lift is this. Acceleration of lift is this. So 1.2, and it is positive, 1.2 into tau square. This is equal to 2.7 meter. Now just solve this question, and I think we are getting this. under root of, if you solve this, we will get under root of 2 into 2.7 divided by 11, and if we solve this we will get around 0.7 second. So this is how we have solved using the ground frame. And if we want to calculate distance traveled by the bolt, then we will discuss later also, but let me tell you here also, distance will be this distance plus this distance, and displacement will be this only. We have already calculated. Okay students, now let's solve this question using relative motion concept, and you will amazed to see that this question becomes so easy. You can solve this using just one formula, under root 2h by g. Okay, so with respect to lift has come to rest. Lift has comes to rest, and you must know that we are solving with relative to lift. We took upward as positive, and all the values are shown here already. So let's find initial velocity of bolt with respect to lift. So initial velocity of bolt with respect to lift will be initial velocity of bolt minus initial velocity of lift, and we know that the initial velocity of lift and bolt are both same, 2.4 meter per second upward. So this is 0. So relative velocity, initial relative velocity, that means that t is equal to 2 seconds. That t is equal to 2 seconds. Now let me tell you one thing, that this is the time interval after 2 seconds. After 2 seconds, right? Here in this equation we always use the time interval or time duration of the event. So event started at t is equal to 2 seconds. So if somebody asks at what time it will strike, then you must say it will strike after 2 plus 7, that is 2.7 seconds. So now find acceleration of bolt with respect to lift will be acceleration of bolt minus acceleration of lift. We know that acceleration of bolt is minus of 9.8 meter per second. Acceleration of lift is 1.2. Why I am writing a plus? Because acceleration of lift is upward direction 2, so it is coming minus 11 meter per second square. So if I solve in the frame of lift, means we are actually talking about what B has observed. So B must have observed that this lift is at rest, like you are sitting in your room, and fan has fallen from the ceiling or bulb has fallen from the ceiling. So when it will fall, you will obviously observe that the relative velocity will be 0, and according to this person, the acceleration of this bolt or bulb, whatever now you want to say, this is 11 meter per second square downward. Minus sign indicates that. And to strike the floor, the distance that this bolt must traveled, what was that? 2.7 meter. 2.7 meter. So total displacement, now we are seeing that acceleration is in negative direction, displacement must be is vertical downward direction. So let's say downward is positive, because we are seeing all the vector quantities are in downward direction. Displacement is equal to ut plus half d square. All these terms are relative only. So displacement, we know that as we have taken downward as positive 2.7, u initial velocity is 0, relative velocity, plus half into a is also positive, into t square. So you can see the time is still same, under root of 2 into 2.7, that is 5.4 divided by 11. Yes, the answer is same. So first part is actually easy, but I explained you using ground frame also. So now students, let's solve last part. They are asking in ground frame what is the distance and displacement by the bolt. So I already told you earlier also. Let's discuss it again here. From the ground frame, according to person A, we can see the particle has finally come down, and the displacement will be SB, and we have already calculated, we know how to calculate displacement. This is going to be the displacement. So displacement is already calculated. You just have to put tau is equal to 0.7 second in this equation, and you will get displacement in the ground frame. The main thing is distance. As you can see, particle has first gone upward, then it has come to its own original level, and then some distance downward, that is SB. So total distance will be equal to this plus this. Suppose the maximum height achieved by the particle above its original level is h. So I will say distance will be 2h plus magnitude of displacement, this. And we know that the maximum height achieved by the particle can be written as u square by 2g, u square by 2g, right? And 2g, because yes, during free fall acceleration will be g only, and they are asking in ground frame, plus the displacement of a particle in this direction. So this, and let me just solve it. Now u know that u is 2.4 square by 2 into 9.8. Now plus for displacement, let me solve the above equation, ut plus half d square. So magnitude will be mod of 2.4 into tau. Tau is zero point 0.7 minus half into 9.8 into zero point 0.7 square and modulus. So I have to solve this equation. Let me just solve it now only. So we will get 2.4 square divided by 9.8. So this first term we are getting here as 0.587. Okay, fine. And what, how much is this term? Let me solve it. 2.4 into zero point 0.7 minus 4.9 into 0.49, this is 0.7 square. So we are getting minus 2.401. Let me just check it once again. I think I made some mistake. 2.4 into zero point 0.7, yes, minus I'm getting 4.9 into 0.49. I think this is right. So okay, minus 0.721, modulus of minus of 0.721. So yes, displacement of B must come negative, but we have to take the modulus of it, and finally we will get answer 1.308. So 1.308 meter is the answer. I hope students you have understood this question, how we approached. We solved using both method. I tried to explain you as easily as good possible, as so that you can understand well. Okay, students, do subscribe the channel if you have not subscribed till now, and also don't forget to press bell icon so that you get the notification instantly. And yes, in the coming videos, I'm going to obviously solve all this Erodos problem. Apart from that, I am planning to launch a series in which I will solve all the JEE advanced problem uh, that came in last 10 years. So that will be really helpful for you. And if I will get time, then I will also make a series for um, NEET also, NEET aspirant also. I will choose good problems in which normally students get stuck, and I will post video solution for those questions, and I think that will also be very helpful. Okay, students, happy learning.